Alright guys, so I made this whole video, recorded it, and then my computer restarted, and so I lost it all. It was 25 minutes, so I already did all the work. So I'm just going to talk through them, but here's all the answers so you can kind of check yourself at least. Let's zoom in a little bit. Always remember GCF is the most important. So this first one, I GCF'd a y out, and we just kind of divide the y out, and y to the 8th divide out, gets me y to the 7th. The next one, again, GCF. Can't stress that enough. And we factor out a 5a, and we're left with this after we factor. Again, right here, this is a trinomial, but you can't x factor it. You have to have an x squared x, and this is not following that form. Okay, factor by grouping, we split them, factored an x squared and a 4 out. They look at the same, and we were able to pull it out. Number 4, we were able to factor by grouping, get the 3x squared out and the 2, and then we get x minus 3. They look at the same, and we were able to pull that one out. Same thing, number 5, 5x squared, and then negative 1. Perfect. And the last one here, we get x squared minus 4. We could actually break that down further. That's the difference of perfect squares. So this could actually become x minus 2 and x plus 2 and then 2x plus 5. So that one can actually be factored even further. That one's kind of a tricky one, star. These ones are nice and fast, basically just multiplying. When we have x squared in the front, there's no number. You could set these up very fast. 81 over 18 is going to be 9 and 9. 45 and 14. So on and so forth. I'm just going to kind of show these up here. Number 10, a special notice, we have 3 and 5. There's no two numbers that multiply to 3 and add to 5 though, so it is convenient that, or sometimes it is inconvenient that we get these non-factorable ones because you think it's going to factor, but it doesn't. So it's possible. Okay, and the last of the page here, again, still no values in front of the x squared, so it's basically a straightforward, set up that magic x, find your two factor pieces, and put them into those binomials. The more difficult ones are when we have to get a problem with the number in the front. So we have 2 in the front, so the reason we got 30 up here is 2 times 15, and we broke it down to 6 and 5. A lot of people aren't breaking these down. Once you got that, then you're going into factor by grouping. Okay. And again, I'll go over this probably more in depth tomorrow, just because I just want to at least get these answers to you guys. Here's the answer over here, 3x minus 2 and x minus 10. Moving on down. Again, getting these top numbers by multiplying the front numbers, split that middle term, factor by grouping basically. Pause it if you need more time. Okay. 17, you can factor a 5 out in the very beginning, and then it makes it a lot easier to solve. Notice that this answer right here is incorrect because there's no 5. You have to leave the 5 out in the front for it to be correct. Okay? And number 18, it's not in the form of x squared x, and I can't GCF anything, so this is not factorable. Alright, now we get to the difference of perfect squares. We're going to go ahead and notice there's a perfect square, and a difference, so it's a negative, so we can do this x minus 9, x plus 9. Same thing here, different sign, both perfect squares, so 10x, 11y, 10x, 11y, negative and positive. Number 14 is a good one because 2 is not a perfect square, but you can factor 2 out, which leaves me with x squared minus 100, which is a difference of perfect squares. Number 22, that plus sign right there is my key, that this is not factorable by difference of perfect squares, and there's no GCF, so it's just plain not factorable. Number 23 and 24 are nice problems where you have to GCF first. So you have to pull 4x out of here first, and then you can factor. Leave 4x in the answer. And here we're going to divide by, factor out of 5, and then we can go ahead and do our factoring by splitting the middle term, and we get our answer over here. Okay, number 25, we have this rectangle has the area of this with its length x minus 2 to determine the width. Well, if I factor it, I end up getting these two pieces here, and the length is x minus 2, so what is the width? It's got to be the other piece. As far as these, we can go over these ones in class as well, but let's just get you the answers real quick. We have this one is a positive 20 right here, so we're looking at, sorry, negative 24 right here is the baby. Again, just factor and kind of look for the ones that match up. This one does factor down to x minus 6 and x plus 4. And x minus 6 is this part of the baby, and x minus 4 is that part, so that's how you get that piece. Okay, the one right below it is going to give us the horse. So we were able to factor this one out if we were doing the work as 2x plus 5 and x plus 4. And then over here is our pug, and that is factored as x plus 5 and x plus 2. And then the last one has to be the cat. X plus 5 is one of them, and then we're going to get the other one is, I believe, 2x minus 3. Okay? All right. The whole back page is a review page. I'll just spend time tomorrow going over those ones for you guys, okay? So, doodles.